All right, looks good. So nesting. There's nothing stopping us from nesting if statements inside each other. You can have as many as you want. Now, if you find yourself nesting like 4 or 5 if statements deep, you might have bad design of your code. It'll function, but that's messy. In fact, some people have a hard rule that they'll never go deeper than like 3 levels, and if they are, they need to change how their code's working because otherwise it's too complex. But you can nest. So for example, here's some code to check which quadrant you're in a Cartesian coordinate system, ignoring 0, right? So first I ask, if x is greater than 0, right? And the reason I ask that is I know if x is greater than 0, I now know it's at least quadrant 1 or 4. So I ask if x is greater than 0, okay, let's say it's true. Then we go in, then it's one of those 2 cases. Is y greater than 0? If it is, well, now I know it's quadrant 0, quadrant 1. Otherwise, if y is not greater than 0, well, okay, then it's going to be the 4th quadrant. So this nesting, we can nest like this. But of course, think for a second the first 2 if statements there. If I print out the first quadrant, that means x is greater than 0 and y is greater than 0. I could have wrote this like this. I didn't need to nest these things. I could have just used compound expressions by checking is x greater than 0 and y greater than 0, then it's the first. If x is greater than 0 and y is less than 0, well, it's the 4th quadrant, and so on and so on and so on. This is equivalent. It's actually technically not because here y could be 0 and it would still say the 4th quadrant, but we're ignoring that edge case for now. But it's the same thing. They're functionally, effectively doing the same thing. It doesn't really matter which one you use. Use whichever you're happy with. If you think nesting makes more sense, in your case, do it. If you think making compound expressions, do it. But remember, you don't want to nest too deep, things get too hairy, but you also don't want your compounded expressions to get too hairy because that can get really, difficult as well, hard to follow. So maybe you come up with a compromise and do like 1-level nesting by splitting the expressions in half or something. It's entirely up to you. You can make it as deep as you want. There probably is a hard limit on how deep you can go, and then Python will say, no, I'm done, stop. I don't know what it is because you're probably not going to find it. You could do that, but you're probably making really complex code, complicated code that's hard to follow. Okay, any questions about that? Was that a question? Did you have a question? No? Not even? Hello? All right, never mind. Oh yeah, and of course, to the question about how best to prep. Also the text exercises that I know you're all going through all the time anyways, right? If you go through those, if you were reading through the text and going through the exercises and you don't get 100%, you should feel bad about yourself. Because if you've been doing that, you're going to do just fine. If you don't get 100% and you were earnestly doing that, I probably messed up by making the test weird or something. So if you're going through that, you're going to do just fine. All right, so what have we learned so far? I hate to tell you, you've learned a lot. Raise your hand if you've never programmed before this class. All right. Take a moment to you really should take a moment to appreciate how much you've done, how much you've learned. You've learned a hell of a lot. And it might not feel like it, but we have. We've learned about values. Those values have types. We have variables, and variables, variable, it's not listed there as a throwaway thing. Yeah, we learned about variables. Variables are exceptionally powerful. They're critical. If we don't have access to variables, we can't really do anything interesting with our programs. So we have variables. We know how to print stuff out, produce output. We know how to get input. We write functions. That's a big one. Functions, whenever you're writing code, you want to be writing functions. So good thing you know about functions. We know about Booleans. And we know about comparison operators, and we know how to make use of these things for things like the conditionals, the if statements. We know our basic propositional logic as well. Each of these topics, in and of themselves, aren't overly complicated, right? Chances are you've been able to follow along each of these topics and be pretty happy with it. And this is where a lot of students start to struggle. And this is where my answer on how to improve is more practice. That's really the only trick to this, more practice. If you look at all these things and you say, yes, I understand all of those things, but whenever you give me a problem to solve, I like freeze. I just don't know what to do. It's because you need more practice. It's easy, maybe I'll use the word, it's simple to understand each of these things individually. It's difficult to understand how to use them together to solve problems. That's where the difficulty comes from. So you might be the greatest expert on each of these things individually, but if you can't put them together, if you can't use all the tools in your toolbox to do something interesting, we're not really getting anywhere. So the difficulty comes by putting these things together to solve more complex problems. Now, if I'm writing code, I get a problem and I want to write code for it. There's no manual for me to go, okay, step by step, how best to approach this problem. That doesn't exist. That's what you get with practice. You get that intuition, you get a feel for it. This is where like the art more than a science kind of comes up. There's no right way to do it. Now, there are strategies I can recommend to you. There's strategies a lot of programmers would recommend on how best to approach these things, but there's no right way to do it. You just kind of need to develop that intuition through practice, practice, practice. So here's what we'll do. What I suggest is the bottom-up incremental strategy. First of all, you get a big problem. Before any of this, you got to break that problem down to its bits, the small bits. It's hard to solve a big problem. It's easier to solve multiple small problems that can be put together to solve the big problem. So raise your hand if you've been working on assignment 1, right? If you're far enough along, right, if you're doing the count start, if I just threw at you, now you got to remember, the assignment is written in a way to help you along with writing this code. But imagine that assignment description just said, write some code to tell me the density of Starbucks within some area. You're going to go, what the F? Like that's, how do I even start that? But no, I broke it down for you. First I said, okay, write the code to calculate the area of a space on a sphere. Sphere-ish thing. Then write the code to count the number of Starbucks. Then write the code to do the density calculation, right? So I broke it down so it's easier to solve the smaller problems rather than trying to solve the big one all at once. Where the end goal is to solve the big problem, of course. So break the problem down into its smaller bits. Then what you do is you decide, okay, I want to write a function. I want to write a function to do something. So what I do is I start with an empty function. Literally nothing in there. Have it return 0 or something, some arbitrary value. Hit run. Make sure it does what I expect it to do. It better. If it doesn't, I did something wrong. Maybe it was a syntax error. I don't know. But write a function, have it return 0. I call the function, make sure it gets me back 0. If it does, good. So far, so good. Then write 1 or 2 lines of code. Write a little bit of code. Then run the function again and make sure it does exactly what you think it should do based on what you did. If it does, good. If it doesn't, well, now you probably have a good sense of where your mistake was. Probably in that 1 or 2 lines of code you wrote. So if it works, then you're happy, good. Do it again. Write a little bit more, run the code. If it works, good. If it doesn't, chances are now you know where the issue is. The easiest way to debug is by not really having the bugs in the first place. And this is the strategy of not having the bugs in the first place. I mean, the bugs will be there as you're building it, right? You hit run, it doesn't work, you tweak it. But when you're finished writing that function, you're probably going to be pretty happy it works. That said, we're still going to write our assertion tests because they are not just there to make sure the function's correct the one time. We want to ensure that it's always correct regardless of any changes that happen elsewhere in the code. And you just repeat this process. This is a great strategy, and there's going to be half the people in the room that's being like, oh, great, yeah, what a great idea. But there's going to be another half of the people in the room that go like, yeah, great idea, but why don't I do that? Because it should seem rather obvious of why this is a good idea. But how many of you really been doing this? Or how many people have been kind of like sitting down, writing your function, hitting run, going like, damn it, it didn't work? Raise your hand if maybe that's you. Of course, we're all like that, right? We want to just, get it done. In spite of everything I'm telling you, I fall for that all the time too, right? Like, I know this is going to work, and I hit run. Oh, shit, it didn't. But remember, that's programming. So this is a good strategy for any problem solving. Solve little problem step by step. It also helps ensuring that it's correct as you go. Because if I wrote 100 lines of code and hit run and there's a bug in it, I have to go debug 100 lines of code. Where is it? If I wrote 2 lines, ran it, 2 lines, ran it, 2 lines, ran it, and then finally I find the bug, well, I'm probably going to know where the bug is. On the new lines I added, probably. Maybe not, maybe it conflicts with something earlier, I don't know. But it's a little nicer this way. It's not foolproof, but it's very handy. All right, we're going to solve a problem. Here's what we're going to do. I'm going to walk through a problem-solving strategy for this particular problem I'm going to explain. It's going to start by, it's not an overly complex problem, don't get me wrong, but we'll agree that it has several parts to it. And I'm going to walk through a strategy for writing the code for this. The way I'm going to do it is maybe not the way you're going to do it, and that's fine. There's no right way to do this. All that really matters is that you've got functioning code and it's good code. But you could do that an infinite number of ways. I'm just going to show you one way. If you don't like the way I do it and you want to do it another way and it works, awesome, good. It doesn't really matter. So don't think what I'm about to show you is the correct way to do it. It is a correct way to do it. And if you think you do it a different way, fantastic. So here's the problem. Some car rental place wants us to write a program to quickly and easily calculate the charge for a customer. All right? They're going to want to know, based on the rental agreement, how far they drive, how many days they had it, how old they are. Then we're going to want to be able to calculate the charge that they're going to have. All right? Sure, someone can do this by hand, but wouldn't it be nice if a program can do it like that, right? So this is what we're going to need from the customer. We need to know their age. We need to know what rental agreement they want. We want to know how many days that they're going to rent the car. And we also need to know what the odometer readings are when they start renting the car and then when they get it back, because that's how I'll figure out how many kilometers they drove. Okay? If the classification code is B, if the rental classification code is B, they have a base charge of 20 bucks a day plus, 30 cents for every kilometer they drive. Classification code D, on the other hand, is $50 a day plus 30 cents for every kilometer driven above the 100 kilometer a day allowance, the average allowance. How do I word this? What did I say? Above the 100 kilometers a day average allowance. And then all renters under the age of 25 are charged an additional $10 a day, because you got to remember, ageism doesn't apply to younger people. We're allowed to be discriminated against. It's just old people that aren't allowed to be discriminated against, right? So that's what we're going to have here. That's what it is. Now, not overly complex, but let's take a moment and realize what we got to do. Okay, we're going to need to know what their classification code is. We need to know their age. We need to know how many kilometers they drove. Then we're also going to need to know like the average number of kilometers they drove a day and figure out, like if it's classification code D, then we also need to figure out, well, how many is it above the 100 allowance that they're allowed to have? So if they drove like on average 130 kilometers a day, they really only drove 30 kilometers above their 100 kilometer a day allowance, right? So all of these bits are simple, but we got to break it down and keep it easy. So let's take a moment and think. Okay, so I'm going to have this big function. What am I going to do? So the first thing we want to do is read the problem and understand the problem. Your job as computer scientists, coding is only one part of it. I know I'm a broken record. Your first step is, what is the problem? Figuring that out. When you come to office hours and you say to me, I don't even know where to start. I don't even know what the problem is. Well, don't get me wrong, I'm going to help you. But you got to remember, that's part of like the assignment. Part of your assignment is figure out what the hell I'm asking you. Because that's part of your training. That's part of the job. Then it is work out how you're going to break this down in like a solution. And then code it. Coding is the last thing you do. So what is the problem? Well, we realize half of this problem is like I/O, input, output. We got to get all this information from when they get their rental agreement, right? Their age, how many days, odometer readings, etc. And then we want to print out the final result. So here's my base. Let's clear all this out. Okay, obviously, this isn't going to work because I don't have that, but here's like the general idea of what I want to have. I want to ask for input. Then based on that input, I'm going to do some calculation. And then once that calculation is done, I want to print out the result. So that's what I have here. This is the general idea. Now, I always say, make sure you're testing your code, but I/O is difficult to test. So whenever you want to test like the input, for example, this is really the best you can do. Because you just make sure, okay, did the input come in, like did I get the values I expected to get and were they the types? We're going to have to do it like manually. Deal with it. So I hit run. Age, they're 10. Their classification code is, I don't know, 10. I know that's not valid, but it doesn't matter for testing purposes. Number of days, 10. Odometer, 10, 10, there. And we got 10 int, 10 string, 10 int, 10 float, 10 float. Yeah, that's what I want. Great. Okay, cool. So I'm pretty comfortable with this amount of code. But of course, this doesn't actually solve anything yet, right? Let's get rid of that. This doesn't actually solve the problem. This is just the I/O part. But yeah, look, we got it out of the way, and I'm pretty happy with it. And this is a big part of the problem still. All right. So the above example of reading inputs is sufficient. However, we're far from solving the problem. Okay, calculate the total charge. So let's start with some like base. Here. I want to start with this. I'm going to zoom out a titch. I'm going to create some function that I'm going to call on that line up here. I want to give this function all of this data, and I want to get back the total charge. So I'm going to write a function called calculate total charge. And this is obviously not correct. This is obviously not done. It might not even be a good layout, but I just wanted to come up with a layout to break down the bits I'm going to need to know. So first, we'll start with, well, their total charge is 0 because they haven't done anything. I'm going to want to know how many kilometers they traveled. I know I need to know that. I'm going to want to know the average kilometers they drove over the days that they had it. And then if it's rental code B, we want to do one calculation. I think I have it in the comment. It's $20 a day plus 30 cents for every kilometer driven. Otherwise, let's just assume otherwise it's rental code D. We're going to do some other calculation. But the calculation we do will depend on the rental agreement code. And then finally, we have to do some check to see if they're under 25, because that's the rule. If they're under 25, they get an extra 10 bucks a day. And then finally, return sum total charge. This is just a skeleton layout. Obviously, there's no functioning code in there yet. It's just laid out for me such that it's helping me break down the problem into the smaller problems. Now let me ask you this. The first subproblem I want to solve is, what's the total kilometers driven? I know how to do that. That's pretty simple. I just need the starting and ending odometer readings. It's the difference between the two. So let's do that. Let's write a function here. Okay, that's obviously not going to work. Total kilometers. I mean, there's really only one line of code in there. Most of it's the doc string. But how do I calculate the total number of kilometers? Well, take the ending odometer reading and subtract from the starting, right? If they rented the car with 20 kilometers on it, and they give it back with 30 kilometers, well, they drove 10, because 30 minus 20 is 10. That's how far they went. We all agree with that? Yes. Okay, good. We passed grade 2. Yes. So there we go. We're happy. I wrote a function for this. Now, you might look at this and be like, really? You wrote a function for that? You could have just done the difference calculation on that line up here, right? Presumably, this bigger function, right? So this will call total kilometers traveled, and it'll take the odometer readings. So this function will call this new function I wrote. And you might say, well, why even write that as a function? You could just do like our end minus start. You could just write that right in that function. And you're right. If you want to do it that way, go ahead. But I like writing it in a function because, to me, odometer finish minus odometer start, that's a pretty self-descriptive line of code, right? But you know what's even more descriptive? A function called to a function called total kilometers. Because I go, oh, it's calculating like a total number of kilometers. Chances are your average person could look at odometer finish minus odometer start and be like, okay, that's like how far they drove. They could probably piece it together. But let's make it even more explicit by giving it a function. And on top of it, it's easy to test functions with their certs. And we like to be able to test our code easily. So functions are great. It's also, like, who here agrees? That's an easy function to write. Put your hand up. It should be. If at this stage it isn't, come see me. It's easy. And then it's easy to confirm it's correct. Now I know I've solved a subproblem that we need to solve the bigger problem. The subproblem is solved, and I'm damn certain it's correct. So I'm happy to move on to the next part, which is great. This strategy, if I just start writing lines and lines of code in this function, there's nothing wrong with it. But it's harder to test like individual bits in a bigger function than it is to test a whole small function. Remember, functions have cohesive, coherent They're like functional units of what do they do. And this is a functional unit that tells me the total kilometers traveled. And I can test that really easily. And it really helps that incremental approach of problem solving. Problem solving. I'm getting tongue-tied. Now, here's another one. I might want to know the average kilometers that they drove a day. Because I'll need to know this for that classification code D, if they have classification code D. And, well, I can calculate an average pretty easy. How far did they go over how many days? So this function can take the total number of days that they had it rented and the total kilometers they drove, and then just do the calculation. Just like that there. And once again, you might say to yourself, that's such a simple line of code. Why would you put in a function? You're right. You don't have to. You could do it however you want. But I think this makes it really easy. Once again, someone can look at number of kilometers divided by number of days, look like, well, that's like, averaging it out. But what's even more clear is average kilometers per day, spelling it out with a function name. And it's going to be easy to test. It's going to be easy to know it's correct, which makes me happy because then I can carry on writing the other bits of the problem I need to solve, confident that what I have is correct. Really good. You might say to yourself, so look, if this function takes number of kilometers, presumably the only way we would know what the total kilometers is if we called the other function first, calculate total number of kilometers, right? We need to do that difference first, and then once I have that, I can pass that value to this function. And you might say, you could have just passed the starting and ending odometer readings, have those as parameters to this function, and then have this function call the total kilometers traveled. Right? What I mean is, here, let me copy this. I'm going to get rid of the doc strings just for the sake of space. And these tests here. Okay. So if I were to want to call these functions, I would have to say like, okay, total KMs, and maybe like 10, 20, right? And then let's say they had it for 2 days, and then I would give it total print. Great, I could do that calculation, right? I call the one to calculate the total number of kilometers driven. Then I pass the result of calling that function to this new function. Pardon me for a moment. I'm just going to plug this in because the battery is dying on it. I just have to be sure not to wander too far. Okay. All right. Now, what you might think to yourself is, you called this function, gave its return value to the next function to use. You could have just, what if here, I'm not going to add the type in, so I'm just going to be really lazy. O-S-O-E. Traveled. O-S-O-E. And then here, I could just take total k divided by number of days. And then I don't even need this other function call, right? I could just go like this. Oop, what am I doing? Oh, right. 10, 20. Oh, what am I doing wrong now? Oops, it's a 0. There. I could do this. So I just had one function call another function within itself. If you think this is a good idea, great. It's fine. Now, there's nothing wrong with this. I want to be very clear, this is fine. But I will warn you that, and this is not a bad thing, it's just it could become a bad thing. You've now made one function dependent on another function, which isn't bad. But sometimes it's nice to make it so it's like this. Some people would say, well, this is a little nicer because now average kilometers per day, that function, doesn't depend on another function. It just needs a value. And it doesn't care where that value came from. The fact that it came from a previous function call is good. But now, average kilometers per day really doesn't depend on total kilometers being an existing function that they could call. It only cares about getting a value for how far did I drive. So some people might argue this is better, but it's entirely fine if you thought, well, why not have that function called the other function to calculate the total kilometers within itself, you know. There's nothing wrong with that. Now, this one's the tricky one. I would say this is probably the trickiest one here. Let's I'm just going to get rid of the docstring for readability here. So here's what we do. Kilometers above average. This may have sounded complex, but now, if I know what my average kilometers I drove is, it's easy to tell me, sorry, average kilometers a day I drove, it's really easy for me to tell you how many above 100 I drove. If the average number of kilometers is above 100, just tell me how much more than 100 it is. Return the number above 100, the average number kilometers minus 100. If I give you 101, is 101 above 100? Yeah, true. So what's 101 minus 100? 1. Well, yeah, they drove 1 kilometer above the 100 allowance that they had. If it's not above 100, well then they've driven 0 kilometers above their 100 a day allowance. Simple, right? Any questions about that one? So now we've solved all these individual bits. So now I'm feeling a little bit more comfortable about how I can put this together to solve the bigger problem. I'm just going to copy all of this. And then we'll talk about it in Colab. Okay, cool, it's happy. Get rid of the docstring. And then there. By the way, this is totally valid. You can totally do this. If your parameter list, if the number of parameters you have just starts to get really long, if the line is so long and it annoys you, you could just kind of like add like new line each one, just so it's kind of nice, a little easier to read. So I just did that here for the sake of readability. So we set up the variable for our total charge. Well, the total charge starts at 0. Kilometers, total kilometers traveled. Well, that's going to be just the function call. We already wrote a function that we know works called total kilometers. I know it works, so I'm going to get back to total kilometers traveled. Now here, calculate the average. Well, I wrote that function already. I know it works, so I'm confident with it. Calculate the average. I check if it's rental code B. If it is, I just do that total charge is 20 times number of days plus 30 cents times the number of kilometers they traveled. If it's not B, presumably it's D, well, it's $50 a day times 30 cents times the number above the average that they calculated. And here, I actually just did the function call in the same line as the calculation. And then after all that, if they're 25 or under, or sorry, if they're under 25, add 10 times the number of days to the total charge. We haven't seen the syntax yet, have we? This is a shorthand. This is shorthand for total charge equals there. That's a shorthand for total charge equals total charge plus something. You'll see that shorthand a lot. And then when I'm finally done all that, return the total charge. Any questions about this here? Now that it's done, oh yeah.
So does the shorthand work with like all operators?
Yeah, there's like plus equals, multiply equals, subtract equals. Honestly, I assume it works with the divide equals. I've never done it actually. You can try it. Try it, let me know. In some other languages, there's even a further shorthand where it's like just plus plus, which means just add 1. So, anyways, I'm not 100% sure why the shorthand exists. I've heard a story. I don't know if it's apocryphal or not. But the story I heard is, if it's like 1980, your monitors were really shitty and only had so many characters wide. And so if you were let me go back. This is a lot more characters than this. So it saves it from going off like the screen. I don't know if that's true, but that's what I've been told. Really, my guess, it's just programmers wanted to be lazy. But we call it syntactic sugar because it's nice, but really it's just because we're lazy. Remember, if we weren't lazy, we wouldn't be trying to get the computers to do all the work for us, right? So if you're happy with this, good. But I mean, now that it's written, like I'm happy, but maybe I would think to myself, you know, maybe I should do what I call refactoring my code. It's correct, but maybe I could clean this up and change it a little bit to improve it. Like, for example, maybe I don't really like this there. Maybe I could do like, times, okay. Right? Now maybe it's a little nicer. And you know what? Average kilometers, I only really need to know this if it's rental code D. So maybe it's better served in there. And you know, maybe I should have had a constant for the age, because maybe in the future they decide, like here, age less than 25 probably knows what it means, but if I made this a constant, I could call it like the screw young people constant or something, right? And then maybe I decide later to make it even older people get screwed over. I don't know. But it's not just having it working. Now I start thinking about, could I make it better? Could I refactor it to clean it up a little bit? And yeah, you could. Anyways, we'll stop there. Remember, if you have any questions, concerns, thoughts, you want to chat, come visit me when I'm lonely in my student hours. You know where to find me. I'm in the annex. Talk to you later.